Yeah, hi, we're here with Benjamin Baer with ScaleMP, talking a bit about making big systems out of small systems. So how's the show been?
The show's been really good. I don't think it's as crowded as it has been in the past, but I think the people that are here are very serious.
Yeah, I've kind of seen that too. I've heard some of the same things from other vendors. And really, there's a few companies here, and you're in the lead, I think, from what I can tell, of taking small distributed systems and being able to, through magic, pin them together to make big shared memory systems, making big SMP out of small boxes. And it seems like this is the year that that's sort of breaking out.
Well, we hope so. ScaleMP has been doing this for a few years.
How many customers do you guys have?
We have over 150
today.
Everything from the largest, San Diego Supercomputing Center type implementations with thousands of nodes or thousands of CPUs, down to the smallest, 2 and 4 node type SMP.
And the range on this is from 2 and 4 node up to 16?
Up to today? Up to 16 in a single instance of an operating system, right?
And the thing that is kind of resonating with me is the ability to be able to build unbalanced systems. Systems with some CPU, but with a lot of memory or a lot of I/O. Is that sort of the big picture here?
Yeah, so today we can aggregate using virtualization technology. It's a pure software solution, up to 16 nodes of x86 in varying kind of configurations. The largest system being about 128 cores and 4 terabytes of memory. So any combination of those, you can have a single CPU or a single core, well, not a single core, but a single slot, with a lot of memory, up to 4 terabytes of memory, or some derivation.
But the interesting thing that you just were telling me is that the way you do this, telling someone to go out, buy a 2-socket board with the hottest Nehalem you can get, 6-core, 4-core, very hot, very fast, but then go out and buy the cheapest, 2-socket, back revved, oldest system boards you can get, and then populate the memory.
That's right, and max out the memory and end up with a single chip, single processor with up to 4 terabytes of memory behind it. Now the benefit of doing that for those customers isn't necessarily the configuration, but the fact is it'll cost you a lot less to get the cheapest processors with a lot of memory than it will to get a Nehalem processor with a lot of memory.
And your software is recognizing, it will deal with system boards that have disparate processors, but it's going to use the fastest.
It'll actually just ignore the processor altogether. So our system only recognizes the fastest processor within that image, within those nodes. But it'll recognize all the memory and all the I/O.
And on those nodes, we have a single instance of an operating system. It's an SMP model.
That's right. That's right. The operating system is completely unaware of what's underneath it and how many nodes there are. Our software, our virtualization software, just makes it aware of the number of processors and the amount of memory and the amount of I/O that's there.
Very cool.
The applications run completely separate and apart from the VSMP foundation underneath it.
Very good. Well, thanks very much. It's fascinating stuff.
Thank you very much.
We'll see what happens with it. Thanks, Beth.
Thank you.
All right.